page 2. There's also a homework assignment, which is homework assignment number 13, linear versus exponential functions. We're still looking at tables, and that might seem like a lot of homework because some of you might have not gotten to yesterday's homework assignment, although some of you did try it. Good job for those of you that tried it. But if you didn't get to it, that might seem like a lot of homework assignment number 12, homework assignment number 3. But if you know tomorrow you just have a PBIS lesson, it gives you time to catch up on your homework assignments. And just to give you a little preview of what's going on Friday, we're just having one practice assignment in class. And then the rest of that you're going to be using to catch up on any missing assignments. And that could be done on your own, or you could stay in Zoom. But it'll be more like a catch-up day. So it might seem like we're having a lot of assignments to catch up on from yesterday and today, but you have this day in the middle of the week, Wednesday, to catch up on that. Or you also have Friday to catch up on any other assignments. There will also be a video of this lesson recorded, and it'll be posted up in that Tuesday 13th of your agenda. All you would have to do is click on it as soon as you see it underlined, and if you need any help for your homework, you can go there. We will be giving out your progress reports today, so that some of you might think, oh, really?
Yeah.
Ooh. So actually your progress report is already done. You would have to click on that, not the Friday one. That is not the correct one. You would want to click 1, 2, 3, 4, 5, 6 spaces down here where it says progress report Tuesday 4/13. It says wait for the ready, but they are done, so they're ready. Everybody will have their oops, I clicked on that wrong one. So everybody will have their progress reports available. Remember, you have to turn in 9 of you. Fantastic job. I hope those 9 of you were actually done.
Yeah, they were.
Okay, good.
Yeah.
So now that you're viewing it, make sure that you actually turn it in. And other than that, some announcements for today. We will have tutoring tomorrow from 12:30 to 2 on Wednesday. Not today, we have a meeting today. We have a quiz. Our second quiz will be coming up on Friday, April 23rd. There is no laptop here that you're noticing. It's not here because there is no tutoring today. But for tomorrow, if you do need to come visit us during office hours, click on your agenda. In that Wednesday tab, you'll see this laptop that says tutoring link. All you have to do is click on that laptop and it takes you directly to that Zoom session, that Zoom meeting. I'm not going to click on open Zoom because I'm in this Zoom with you right now and I don't want to mess that up.
Okay, hold on one sec. For Alexis and Emily, I need you guys to put into chat your birthdays, and I think one of you guys got confused. It's not my birthday. It's you're putting in your birth date. So whatever your birthday is, put it into the chat room, or else I will be kicking you guys out. Again, I have yet another student who's trying to log in that I don't know, and I'm locking the class as soon as I have everyone's attendance in. So make sure that you guys are always here on time or within the first 10 minutes, because I will lock class, and the only way that you guys will be able to get in is if you guys message me. So again, I'm still, I'm almost done with everyone's, you realize that that's just to me, and oh my God, see, like that. I just caught one of the kids and they sent me a direct message with the N-word.
Yeah.
But it's only to me. And you got one too?
Yeah.
That's stupid. It's like, okay. Mm-hmm. So, yay. I love kids. Oh, even was dumb and put in a birthday, but not the person's actual birthday. See, this is the reason why I do birthdays, guys. Because, and they put 2003. That's like way off on, birthdays. So, yeah. So make sure every morning, as soon as you're coming in, you need to be giving us those date of births, your birthdays.
as soon as you're joining, that way we can speed this process up and also eliminate any of these interruptions that are not very helpful to our learning environment. Because again, we don't want to take time away from the time that you need to learn all the material that it is that we're practicing. All right, so I'm going to keep going here. If you do need to come to our office hours tomorrow, click on that Wednesday tab for your agenda. You'll see your tutoring link there. Just click on it. It takes you directly to the Zoom session.
All right.
All right,
And
so
I've already done everyone's stuff. So you guys, everyone has already checked out. If for whatever reason your internet, like logs you guys out, you need to send me a direct message, either text or somewhere else, letting me know like, hey, I need to get back in. I'll open up the classroom for you guys to get, let back in. All right. But understand that this is the new process in this class because we have one student. I kind of feel like I know who the student is because so I kind of feel like I know who it is, but it won't change the fact that I have to let the student into the classroom all the time.
right. Yeah.
So the camera is allowed to be on. So if you guys want to have your camera on for today, you guys can. The chat is now, I'm gonna make it so that everyone can talk to themselves and you guys can unmute yourself at this point. So everything is now good because I vetted all of you guys. But as soon as you guys come into class, if you guys would start putting in your birthdays, that way it's a lot easier for me to go through everything and it doesn't take this long.
Mm-hmm. All right. So at this moment, I want everybody to go ahead and click on Docs Shading Grids, Day 2. That is the first activity under the Tuesday tab, which is today. When you click on that, if you are signed in, it'll take you directly to the page. But if not, you have to enter your first name and last name and click on Go. The activity will be paused while I get the majority of you on here. All right, guys, I have Kimberly, Selena, Marifed, Emily, Lizette, Catherine, Jose, Jimena, Melissa, Juan, Danica. Thank you guys for joining us there. I'm waiting for a couple of you. Give you guys about 1 more minute. Again, you can access that through your agenda. It is the first item on Tuesday's to-do list. And you can also get there through Google Classroom if you click on classwork. You just have to do a little bit of more digging here. That's why we simplify things in the agenda. So you would have to look through here to find that Docs Shading Grids Day 2 right there. Want to remind you that today's Desmos activity is a formative assessment, which means it counts for 40% of your grade. So you want to make sure that you are following along with this and we can see who's following along with this at all times. You want to follow along with this, make sure you're completing it to the best of your ability. These questions are not that hard. A lot of them is just your observations and opinions on them. So we're not really looking for this right or wrong answer. We're just having you guys explore with patterns. But at the end of this, you should be able to turn it in just like we did yesterday. Okay. Since we have the majority of you on here, I'm going to go ahead and unpause this and get you guys started. And I'll restrict you to slide 1.
Well, hold on one.
That's right.
No. He sent me a message.
Okay.
So.
New, just joining or lost connection?
Yeah, new.
Okay.
They were in the restroom when they logged in. I was doing the vetting.
Okay.
And they vetted, so.
Okay, good. All right, so if you're just joining us, we are working on our second day of our shading grids activity. Don't forget to check your agenda daily. So go to week 5, click on that agenda. Should open up your weekly agenda here. And you want to click on Tuesday. Our first activity, which we were just getting started with, is the dock shading grids day 2. Click on that and it should take you into our first page here. All right, so we're going to go ahead and get started on this one here. Very similar to what we did yesterday. We're still examining the patterns in our shading grids here. And we're going to write the number of colored rectangles in each grid. And you're still going to continue the patterns for stages 4 and 5. So the only thing that is different is we have different colors and we're most likely going to have a different pattern. So yesterday we talked about those patterns that were increasing. We had addition patterns and we had multiplication patterns. Keep in mind that we said an addition pattern was a linear function and a multiplication pattern was an exponential function. So we're going to take a look and see what's going on here. I'll help you guys out with the first one here. Grid pattern C, if we count all of these across here, there's 1, 2, 3, 4, 5, 6, 7, 8 in that row. And I can count how many rows we have here. 1, 2, 3, 4, 5, 6, 7, 8 rows. So 8 rows with 8 rectangles in them. That'll be 64. Notice I'm using the color green just to keep the color codes here with the grids consistent, but you don't have to. If you want to change the colors, you can go to that pencil mode. And then on the options, you have all of these different colors. So I'm going to go ahead and give you 5 minutes to count your rectangles that are shaded. Write the number of rectangles for each stage. And then take a good look at those numbers, examine those numbers, and determine what pattern do you see between them to help you fill out stage 4 and stage 5. Don't forget you're coloring in stage 4 and stage 5 depending on how many rectangles you have. If you do finish with grid pattern C, do the exact same thing with grid pattern D, the purple rectangles. All right, 5 minutes, and then we'll come back, have some of you guys share your answers and move on to the next slide. And if I see that the majority of you are finishing up this page, I'll open up the next page. Let's see, Sammy, good job. You caught on to that really quick. Jimena, you're doing fantastic. Oh, Melissa, good job. I see some of you are like, I'll try the other pattern because there's less squares maybe. For now, there's less squares. If some of you are stuck with the patterns, think of what we did in yesterday's patterns. We tried adding numbers. That helped us find the next number. And if it was consistent, it'll help us find the number after that. We even had a multiplication pattern, so maybe multiplication will work. Is addition and multiplication the only operations we have in math? No. So if none of those work, you're probably going to have to try some other operations. Good job, Jimena. Emily, you're doing fantastic. Emily Montano, I know there's 2.
No, right now there's only 1.
Yeah.
Oh, some are telling me that they weren't here yesterday, so they're kind of on the confused
Oh,
side.
yeah, okay. All right, I'll help you guys out for those of you that weren't here yesterday. What you want to do is count how many squares are in each stage. So in stage 1, I helped you guys out with counting that for you. There's 64 green rectangles. In stage 2, you have to count each of those rectangles there and find out how many we have. I can do the same, count how many are in this row, or just count them all. 1, 2, 3, 4, 5, 6, 7, 8. So there's 32 squares here, or rectangles, that are shaded green. And here we have 1, 2, 3, 4, 4, 8. So we have 16 green rectangles. So we have 64 in the first stage, 32 in the second stage, 16 in the third stage. We notice something's going on with the numbers. You can find a pattern by asking yourself, well, what do I do to 64 to get me to 32? Do I add? Do I multiply? What other operations do we have? Can we subtract? Can we divide? So see if there's anything you can add by, subtract by, multiply, or divide by that will give you the number 32. And that should be the same for the next stage. We should do 32 plus, minus, divide, multiply to get us to 16. Right, we have about 1 minute and 30 seconds left here. Remember, a pattern is consistent. Yesterday, we kept adding by 2 each time, or we were multiplying by 2 each time. It didn't change the numbers in the pattern. So you want to make sure your pattern is consistent. Yes. And for those of you that weren't here yesterday, once you're done with grid pattern C, you also want to do the same with the purple pattern. Count how many we have here. We have 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9, 18, 10, 20, 27. 27 here. Figure out what pattern we have going on here. 3 to get us to 9, 9 to get us to 27. And what can we do to that 27 to give us the next stages?
Also, guys, if you guys were ever not here for a day, the videos are posted to your agenda and you're supposed to go and look at it too. So keep that in mind that you guys should, if you're ever absent a day, you guys should be watching those videos to see what you guys missed.
Good job, Juan. Yes, for pattern C is correct. I see you drawing question marks. It's good. You're doing fantastic. All right, we're going to go ahead and move along here. You guys, the majority of you have caught on to these patterns, and we're noticing something different is going on here, especially on the green pattern. Yesterday, we talked about our numbers getting bigger each time we looked at these stages, and now we notice we have a 64, and we all of a sudden go down to a smaller number, which is 32, and we can even see it here. We have a lot of grids colored in, and then we have less grids colored in. Can anybody share, either by unmuting themselves or in the chat, what pattern did you guys get? A consistent pattern that took us from 64 to 32 to, or 32 to 16, or what did we do to those numbers to get the next set? Yes, good job. Perfect. We're dividing by 2. Very good. So each time here, we're dividing by 2. 64 divided by 2 gives us 32. 32 divided by 2 will give us 16. So if we do the same to 16, that'll tell us how many we should shade here. Anybody, 16 divided by 2 is? Yes, good job, 8. So you should have 8 colored rectangles. There we go. Repeat the same step, 8 divided by 2. Good job. Thank you, Jimena. We get 4. 1, 2, 3, 4. Fantastic. So already we're seeing this is a little different. Keep that in mind. Now, grid pattern D, a lot of you were already sending me messages for grid pattern D. Grid pattern D, what I do want you to notice is our numbers are actually getting bigger. We go from 3 to 9 to 27, which means if we're getting bigger, what operations should we be using? It's either addition or multiplication. That makes our numbers bigger. And you guys have already let me know in the chat, we are multiplying by 3 each time. So 3 times 3 gets us 9. 9 times 3 gets us 27, which means we'll have to do 27 times 3 to get us 81. If you're not exactly sure what 27 times 3 is, we could do the extra work on the side over here. I saw some of you doing your scratch work on the side. So 27 times 3 is 81. You can go ahead and color that in. There's different ways of coloring it in. Some of you guys are boxing up 8 of these. And then you need 1 more. Doesn't have to be perfect. What's very interesting is what happens on this one. We're definitely going to get a bigger number when we multiply. And that was something some of you guys were mentioning. You're not quite sure when it's multiplying or adding for yesterday's homework. If your numbers are getting really big, really fast, what makes our numbers get bigger faster? Addition or multiplication? Keep that in mind. All right, 81 times 3 will be 243. I see a lot of you saying there aren't 243 in here. So I see everybody going in here, coloring this in. That's only 100, but I see some of you going extra beyond that grid. So if you did that, that's fine too. If you colored in the whole thing, we get it. There aren't enough grids in there.
Yeah, there was plenty of teachers when we did this activity, like ourselves. We were like, no, 204, no, we're not coloring all that.
And you guys
math
actually
teachers are
did. So
lazy.
yeah, that's what I was going to say. I'm like, man, these math teachers were lazy because these students actually do it. All right, you guys. You're like, yeah, because I'm getting graded. All right, so fantastic job here. You guys are doing fantastic with figuring out these patterns. I'm going to go ahead and open up the next slide, which again, is just your observations of patterns. Go ahead and move along to slide 2. All you're going to do is describe how grid patterns C and D, so today's patterns, how are they similar, the same? How are they different from patterns A and B, from yesterday's patterns? So today's patterns, this green one and this purple one, how were they the same? How were they different to yesterday's patterns? Yesterday's patterns were red and blue. So keep that in mind. Think of what we had in yesterday's patterns. Give us about a sentence or two there. And then we talked about yesterday's patterns being linear and exponential. Our linear pattern was addition. Our exponential pattern was multiplication. Will these patterns from today, C and D, will they be linear? Will they be exponential? Or will they be something different from both of those? So I'll give you guys about a minute here.
And if you guys weren't here yesterday, let us know in those boxes that you weren't
Yes.
here. But still, you guys can still make a prediction in the second box.
Mhm. So if you weren't here yesterday, I'll just write it on here. Pattern A, the red one. was adding, pattern B, the blue one, we were multiplying. I hope I'm not getting my colors mixed up. Red, and I'm pretty
think
sure it was
that's
red and
right.
blue.
I think that's
Yeah.
right.
So just to remind you guys, yesterday's patterns. Good job, Lisa. Keep going. Oh, Danica, I really love your response there. Oh, Jade, very good. Good job, Emmanuel. So I'll start you guys off with the prediction here. What do you predict? I predict pattern C will be what? Let me know what you predict. Pattern D will be as well. Exponential, linear, different. I should spell pattern right. There we go. All right, a couple more seconds and then I'll show you what you guys are responding to here. Question 2 is just a prediction. We're not really looking for a right or wrong answer here. It's just what you think. All right, let me go ahead and share what some of you are saying. Gotta anonymize that. Okay, here we go. So you guys are saying pattern A was adding and pattern B was multiplying. Let me know what now pattern C and D is doing. So I have that here. Now pattern C was dividing and D was multiplying again. Very good observation, true. They are similar because in one we multiply it by 3 or we subtract it by the half. To half it means that we're either dividing it or yeah, I guess you're subtracting the half, but it would be consistent. Pattern A and B are bigger. Ooh, good observation. Yeah. Pattern A and B are bigger and smaller in the second one. They're different because yesterday was adding and multiplying. Today it was just dividing, but not just dividing. That second pattern, the purple one, was also multiplying. Yeah, similarities are little squares. Exactly. Good job. See, we're not looking for anything very specific. We're just looking to see, what do you see? Yeah, they're squares. They're being colored. They're different colors. Good. One of the differences that one of the patterns was going down, and the similarities was that they all had high numbers. All right, let's take a look at your predictions. I believe that pattern C will be exponential and pattern D will be linear. The second is exponential because we multiply it, and probably the first is linear. So some of you are thinking C is linear because it's doing something else from yesterday, but you guys, a lot of you are sure that pattern D will be exponential. All right, I am going to open up the next slide and you're going to test your predictions by plugging them in to your table. So we're doing the same thing as yesterday. Notice your tables are colored. The first table is green. The second table is purple. What you're going to do is bring in the numbers that you found for those shaded grids into your tables. So you're going to have to go back and forth between slide 1 and slide 3 to bring in the numbers from your pattern. So let's look at our first pattern. The green pattern, we had the numbers 64, 32, 16, 8, and 4. Type those in. As you're typing them in, take a good look at what's going on with your graphs. Oops, I don't know. Take a look at what's going on in the graph. What kind of shape do you see? Try to remember the shapes we talked about yesterday. Linear has the word line in it. So anything that's linear should be a line. Then we noticed another shape was the exponential. So keep those in mind. Anybody want to share what kind of shapes are going on with these? What your graphs are doing? Don't forget, you can zoom in, you can zoom out. If you do too much of zooming in or too much zooming out, click on that house so you can actually see those shapes. So there is the green graph. Bring in your values from your purple grids. That means you'll have to go back. What were the numbers we had for our grids? 3, 9, 27, 81, 243. So we'll just take 3, 9, 27, 81, 243. If you want to try, if you think you can always try to put in an equation for each of these. On row 4, that's the equation for the green graph or the green table. If you want to take a try at the equation, yeah, good job, Jimena. Yes. If you want to take a try at that equation for the purple graph, you can also do that. But I want you guys to take a good look at the shapes of these graphs. Are any of these lines? Give me a thumbs up if we see lines here. Give me a clap if these are not lines. Something else. What are you guys noticing? Yeah, good job. No, we don't have lines. We have something else. These are curves. So if I'm just looking at that purple graph, which was our multiplication pattern from yesterday, we still see that we have a curve. If you zoom out, you start seeing maybe it's going straight, but then it skyrockets up again. That is our exponential, a curve. So when I look at the green one, that seems to be starting at the top, but it's coming down. That is some what we call decreasing, getting smaller. And we saw that in our numbers, 64 to 32 to 18, 8 and 5. That's not 5, that should be 4. We saw that our numbers are getting smaller, so that is decreasing. So what you want to pay attention to here is that we still have that shape of the curve. When we have curves either going up or down, those are still exponential. Okay, I'm going to go ahead and open up slide 4 for you guys. Slide 4 is open and you can go ahead and click on that. Very similar to yesterday. We have our tables, and what you're going to do is draw more arrows to show how the patterns here, if we have addition or multiplication, continue in these outputs, or if we had different patterns. So when you're looking at a table, we're interested in these Y values. We are going from 64 to 32. What can we do to that number 64 to get us to 32? Think of your patterns in the first slide. From 32, what can we do to 32 to get us 16? And so on and so on. So complete your patterns on the tables. Do the same here from 9 to get us to 27. What do we have to do to these numbers? 3 to 9, 9 to 27. What are we doing each time here? What was that pattern we noticed? And when you're done completing those arrows and showing your pattern next to those arrows, go ahead and explain clearly whether these functions were linear, exponential, or something else. And then explain in a clear sentence how an exponential function grows. Jimena, fantastic job on your tables. Keep going. Melissa, very good. Natalie, good job. Marifer, very good. It's interesting how this class is just trying the purple pattern first, grid pattern D. That one everybody's good with. Everybody's saying, oh, 3 to get me to 9. What can I do to that? I can multiply by 3. That was your pattern from the purple grids. 9 times 3 will be 27. 27 times 3 is 81. 81 times 3 is 243. 243 times 3 will be 729. That's your purple pattern. Now let's go back to your green pattern where our numbers are getting smaller. What did we have to do to these numbers to find the pattern? All right, you guys are saying we divided by 2. 16 divided by 2 is 8, so that's working out here. 8 divided by 4, 8 divided by 2 is 4, and 4 divided by 2 is 2. So now what I want you to do is explain clearly how these functions are linear or exponential. What do you think? These functions are what? And then explain how an exponential function grows. Grow by blank. I have some sentence frames there for you guys to help you out if you need them. If you didn't use them, that's fine too. Good job, Selena. Marifer, good job. Ooh, Emily, good job. Okay, I'm gonna go ahead and share what you guys are saying. All right, a lot of you are saying these are exponential because the lines were not straight, like a linear. Good job, very good. The functions are exponential. I think this is exponential because there's only one where we multiply, but in the other one, we subtract, which is probably linear, but we didn't really get a subtraction pattern. Okay, we said that every time we're halving it. So subtraction isn't the only thing that makes numbers smaller. Dividing something also does. So they're exponential because both patterns didn't line up. They're not in a straight line. Very good. These functions are exponential because they curve. Yes, exactly. That's what we want to make sure we're paying attention to. A curve is exponential. All right, let's take a look at how exponential functions grow. Exponential functions grow if the numbers go up. Yes, very good. And more. If those that we multiply grows and goes up, that's perfect. Exponential functions are growing, and they're growing really fast. And they grow fast when we multiply, when we have a multiplication pattern. Fantastic. Okay, I'm going to go ahead and move you guys along to slide 5. And actually, I'll open up slide 6 too, since these are mainly just some conclusions that we're making. So for slide 5, it's telling you here that grid patterns B, C, and D are all exponential. So those of you that said in the previous slide that these were exponential functions, you got it. B, C, and D are exponential. patterns B and D, so yesterday's blue pattern and today's purple pattern, show exponential growth, that they're growing and they're growing fast. But pattern C is not growing. Pattern C is showing exponential decay. So when we're decaying, it just means decreasing, getting smaller. So what I want you to do here is explain how the multiplier, remember we talked about that vocabulary word, the constant multiplier, that was our pattern. Explain how the multiplier or base of the exponential function determines if the function will grow or decay. So what made our patterns grow? What made our patterns get smaller? That's what it's asking you for the exponential side. So the multiplier, I'll just remind you here, that's the pattern or multiplication or other pattern. Determines what happens with that pattern. How do we know it's growing? How do we know it is decaying, getting smaller, decreasing? So the pattern blank makes the function grow. The multiplier or pattern, what multiplier makes the function decay, meaning decrease, get smaller. And notice they're using the word multiplier. We're going to talk about what that means when we had that division pattern in a bit in our notes. Ooh, Juan, good job. Very good response. Natalie, very, very good. All right, I'm going to share. So Natalie and Juan, you guys did a fantastic job with your explanations. Do you guys want to share it by unmuting yourself, or mind if I read them out loud? Let me know in the chat. There's more of you typing them in here. All right, Natalie gave me permission to read her. She said, multiplying made it grow. Yes, so that multiplier, the pattern when we had multiplication, that made it grow. And then she mentions that dividing it made it decrease. So a multiplier, that word multiplier has multiplication in it, right? So we somehow have to figure out, how does division turn into multiplication? That's what we'll be talking about in our notes, because we have to make sure that we're using multiplication in our exponential functions. But we recognize that there is division in there. So very, very good. The multiplier determines that it will grow if it is multiplied. Very good job, Sammy. I'm going to read Juan's as well. It made the patterns grow by multiplying, and in some we added, but it makes it decay when we were dividing. All right, perfect. So you guys can go ahead and move along to page 2. All you're doing here is summarizing what you have learned today. And also, if you have any questions still left from today's activity, you can let us know in that second box. Oh, yes. I like what someone's saying here. They're wondering about writing equations. So this is an overachiever. No, you're not an overachiever. You're actually fantastic and awesome for wanting to get ahead. That's awesome. Writing equations, we're taking baby steps and we're going to get you to the point where you can write equations. But if I just throw everything to you at once, I can lose students and I don't want to do that. So we're pacing you to make sure you get a very good understanding of the whole concept, of the whole idea, so that when it comes to writing the equations, you're not completely confused. So good job for those of you saying, I want to get these equations. You should be able to write linear equations. We talked about that equation. And we're going to show you basically what you need for an exponential function. So good job for those of you wanting to figure that out. When one question asked if it was linear, exponential, or something else, what is this, that something else? I love that question. That's an awesome question. What is that something else? That is math 2. Just kidding. That's something else. It could be different shapes. For a while, you've talked about straight lines, and now you're being introduced to a curve. This is math 1. This is like freshman level functions. In math 2, you have different shapes. So there could definitely be some other shapes and some other patterns going on. I love that question. Thank you, Natalie, for that one. All right, so at this point, we're done with the
Dog, I think you kicked her out.
No, I didn't. I think she, her internet must have gone down. Oh, and I probably should, allow her to be able to come back. While we're waiting for her, what she was about to say is that you guys are done with that. Go into, Google Classroom, and then you guys can mark it as done. All right?
Damn your shirt.
She should have put her birthday. Oh, that's hilarious. So I'm waiting for her to send me a message. Yeah, she just sent me a message saying lost connection. So give you, again, guys, I'm laughing over Isaac's thing still. Hey, David, can you put your birthday in the chat, please? Hold on, Miss Gomez. Let me make you co-chair so you can do all that stuff. Thank you. And then I can allow you guys to unmute yourself and watch and create your videos and stuff.
I'm back.
Yeah, they were like, you kicked her out, and then they said that you should have put your birthday in the chat room.
That's what
That was hilarious. I just kept laughing over that.
I don't know why all of a sudden Zoom just like kicked me out, and it even took a while to be able to like connect back into it. I'm like, what's going on?
I don't know.
That's a first. All right, you guys. But at this point, I hope you guys were turning in your Desmos.
Yeah, I told them to turn it in. I don't know. I think they were all laughing though. So I don't know if they actually did or not.
Man,
But that was kind of hilarious.
high school students are so witty. Guys, she did kick me out.
Yeah, totally. It was your birthday, Miss Gomez. Put it in the chat room. No, I'm just kidding.
That was funny. All right. So sorry about that, guys, but I'm back. She didn't really kick me out. But if I give her my birthday, then she can really get information on me at this point. My credit. No, I'm just kidding.
No, birthday on your, well, I mean, if I had, like, okay, what's your mother's maiden name?
That's true.
What was your first pet? What was the street that you were, grew up
There's
on? Like all these things, guys, never put on like Instagram chat, like Snapchat, like any of that stuff. Like, what's your favorite color? No, don't do that.
No.
Your mother's maiden name. If you guys get your vaccine, don't be dumb and
Oh.
do what other people are doing and taking a screen, like a picture of their vaccination, like, paper with their birthday on it. It's like, no, just say that you got your shot. Like, woohoo, good job. But don't give them, like, so many people are like taking pictures of that. And I'm like, you just gave me your birthday. Granted, yes, I do know your birthday, but it's in the system. So it's not like I give it to anyone. And that's the reason why I direct message it so that no one else gets it, just me.
Yeah. All right, everyone. So we're going to move on to the next thing. We want to make sure you get some notes in for today, just to clear up a couple of you that keep asking me about the subtraction. Will we ever see subtraction? I do get some of those in the direct message right now. As soon as I walked in, they started popping up, not sure how. And then there's also a question that I have a question. If we see multiply, is it exponential function? Yes, that is the major difference between linear and exponential functions, is that an exponential function, exponents mean we multiply over and over again. So multiplication, a pattern that is multiplication, is exponential. So go ahead and click on your week 5 notebook. Click on that link, sign in. And we're going to finish up our page 2 of our notes. So this was page 1. I know there were some of you that were not here yesterday. So if you would like, go ahead and take a screenshot of this page here. There we go. That's what it should look like when it's fully completed. I'm seeing you guys pop in here into Classkick. Page 2 of your Classkick notebook. Give me a thumbs up if you're able to access. Oh, I see some of you have already started completing it. Give me a thumbs up if you're able to get to your Classkick notebook. Give me a clap if you need more time to get there. Thank you, guys. Okay, I'll give you more time. If you gave me a clap, give me a thumbs up when you are ready.
By the way, guys, also while you guys are waiting, your exit ticket technically did, like pop up for you guys. If you guys refresh your Google Classroom, that does not mean you guys can leave, but that you guys can now get started in between you guys having to wait for other people. And don't forget to mark your exit ticket as done as well.
All right, I see you guys
Your progress report.
Yeah,
not exit ticket.
report. Yes.
Sorry.
All right, so we're going to go ahead and move along to our notes here. This is our 9th day of taking notes but our second day, sorry, of our linear versus exponential functions. We're still looking at tables. But now what you're going to notice with today's tables is that we have decreasing tables, and decreasing means we're getting smaller and smaller. So let's start off with today's objective. It's the same as yesterday. You should be able to distinguish between linear and exponential functions, meaning you know when a table is linear, you know when a table is exponential. And you need to find the rates and initial values. So we're going to start off by looking at a decreasing linear function. Just to remind you, our decreasing linear functions, those were the ones that were getting small or that had a negative slope. And when we had a negative slope, our line was coming down. So keep that in mind. It should still form a line, but it's going down. How do we know that this is decreasing? Well, take a look at your Y values. We're always interested in what's going on with our Y values. We have a 12, 9, 6, and 3. They're getting smaller, which is why we say it is decreasing. If we were to put these in a graph, we would see a straight line coming down. So anytime you have tables, anytime we're working with linear and exponential, you always want to start off by finding a pattern. So that is your first step here. And there's a reason why it's colored green, pink. We thought we have used these colors in our previous lessons, but let's start by finding the pattern. 12 to 9, what do we have to do to that number? 9 to 6, what are we doing each time here? So 12, I can add by a number. 12 plus 2, that's 14. It's getting bigger. I shouldn't add then because that's getting bigger. I can try subtraction. 12 minus something is 9. 12 minus 3 is 9. Does that work for all of these other numbers? Well, 9 minus 3 is 6. 6 minus 3 is 3. So in this table, we see that there is a subtraction pattern. When we have a subtraction pattern, that is the opposite of adding. Adding was linear. Subtraction will also be a linear function. So let's go ahead and go over to your Classkick notebook here. Let's start with moving our objective. We should be able to tell the difference between a linear and exponential function. But for today, we're looking at decreasing linear functions. How do we know this is decreasing? Our numbers are getting smaller. 12 to 9 to 6 to 3. We're always interested in what's going on in our Y values. When you are looking at tables, please start by looking for those patterns. The pattern we notice here is that we are subtracting by 3 each time. If you want to get full credit for your notes, you do have to be showing us these patterns, the arrows with the patterns, just like you did in that Desmos activity. So when we notice we're subtracting by 3 each time, it's consistent. It's the same number over and over again. If you're coming up with different numbers there, you don't have a consistent pattern. So a subtraction pattern will be linear. And notice I'm using the pink color here for my pattern, still to keep in mind that there's 2 things that we need to think about. When we were talking about linear equations, we used the pink for our slope, which was our rate of change. That's still carrying over into this lesson. We're still keeping that same color with the rate of change. And that's what we'll talk about in a bit. All right, you guys already have that in there. So we're gonna move on to our exponential side. So in our exponential side, we know we have a curve when we graph it. And we had our curves that were going up when we were increasing. But in this case, we had a curve that was coming down. So a curve that is coming down is decreasing, and it's exponential. How did we get that curve that was coming down? Well, we had numbers that were decreasing at a faster rate as well, with a different pattern. So we want to take a look at our Y values again. When you have a table, always start by looking at your Y values: 81, 27, 9, and 3. You want to ask yourself, what is the pattern that we see here? What can we do each time to this number before to get us the number after? So 81, if we do something to that, will give us 27. We can try subtraction. But that should also work for 27 to get us to 9. So in this case, if these numbers are too big for you guys to work through, you can even work through the middle numbers. 27, I have to do something to 27 to get me 9. That's a lot smaller. I can work with those numbers. I have to do something to 9 to get me to 3. If you'd rather start off with the smaller numbers, you can do that too. There were some students in last semester that decided they would go backwards, which was a pretty good strategy. So they couldn't really figure out how to go smaller. We had a student that would still go bigger. Oops. So they would try to go backwards. What can I do to 3 to get me to 9? 9 to get me to 27, 27 to get me to 81. They would first start off going backwards and then they would flip that over. We would go in the opposite direction. So if that helps you out, you could also think about doing that. But for now, I'm seeing 3 times 3 will be 9. But that's when I'm going upwards and I need to come down. So I'll do the opposite of that, and that is to divide by 3. So we're dividing by 3 each time. So we might be tempted to say that this is a division pattern. But remember yesterday we said that when we have a pattern in exponential functions, that is called a constant multiplier. It means we have to be constantly multiplying by some number. So division can be turned into multiplication. So that's what we're going to have to do here. When we have a division pattern, this is actually still a multiplication pattern. And all you do is change your division to multiplication. So we're going to switch that division to multiplication. But if we switch it to multiplication, there's something we also have to do to this number. We have to flip it basically. And we get that the pattern is a fraction, multiplying by a fraction. So if I see a division by 3, I'll flip it to multiplication and flip that number, or you could think about just putting a 1 on top of that. So all of these divisions are actually multiplying by 1/3. We changed it to multiplication, and because we changed it to multiplication, we have to turn it into a fraction by flipping it over. So a fraction multiplication pattern is what makes our exponential functions decrease. It's what makes decay, what makes it smaller. So I love the question I got from a student. If we see multiplication, will it always be exponential? Because they must have heard me say that. Yes. Exponential functions, even if you see a division pattern, that is technically multiplying, but it's multiplying by a fraction. So let's go on over to our Classkick side and write that down. We were looking at a decreasing exponential function. This decreasing exponential function had us, it keeps changing. I'm going to zoom in. This decreasing exponential function had us divide by 3 each time. But because we call our patterns in exponential a constant multiplier, we need to change that division to multiplication. So I'll change it to multiplication, but instead of writing 3, I write that as a fraction 1/3. 1/3. It just comes back to the whole concept of what happens when we divide, especially when we're dividing and there's fractions. Dividing, when we are working with fractions, we actually change it to multiplication and flip the second fraction. Some of you guys might remember that. That's exactly what we're doing here. We're changing it to multiplication and we're flipping this number. So that is our fraction multiplication pattern. So there's always 2 steps in these tables. We want to make sure we're finding the pattern first, and these patterns give us a lot of information going forward. So I'm going to go ahead. This information is still up, so you're not missing anything here. Just going to name the patterns here. On the linear side, our subtraction pattern is still called the constant rate of change. It's our slope. Remember, we could have negative slopes. So our slope here is a -3 because our pattern was to subtract by 3 each time. On the exponential side, we were dividing. But when we have an exponential function, we call our pattern a constant multiplier. So we change that division into multiplication by that fraction of 1/3. So go ahead and switch on over to Classkick, and I'll carry this constant rate of change here. Constant multiplier, which was 1/3. So that's what it should look like right now. And we have a couple minutes left, but I want to make sure you see, and so that you don't miss out on finding the initial value. I know there were some of you that wanted some more work, help on that. Also, I would say it's helpful if you draw your graphs here. Keep in mind a linear function that's decreasing is a line that's coming down. An exponential graph that's decreasing is a graph that is curved, and that curve is coming down. If you read it from the left side to the bottom side, we're coming down. All right, so I see a lot of you on the right spot. I'm gonna go ahead and show you really quickly how we find that initial value. So keep in mind your initial value is your y-intercept. When we were writing linear equations, we wanted the slope and we wanted the y-intercept. There's a reason why we're having you take these 2 baby steps, so that when it comes to, I believe, next week, you can write your equations by just remembering 2 steps, constant rate, and then the initial value. So how do we find the initial value? Well, you have to remember the y-intercept can be found when x is 0. So when we have here in our table a 0 on the x side, that is our y-intercept. But these tables don't have x is 0. There is no 0 here. We need to find it, and we can do that by going backwards, moving back. So notice if I'm at the 1 here on the x side, I can move back, and that would bring me back, would bring me to that 0 where x is 0. So that is exactly what we have to do. Or you can think about it, all right, well, there's some number here that if I keep using my pattern, if I subtract that number by 3, it should give me 12. You could think about it that way, just using your pattern still. Some number minus 3 is 12. If you can picture it that way, you can do it that way. Or if you understand the concept that we're going backwards, we're doing the opposite this time, then instead of subtracting by 3, because we're going forward here, to go backwards, then we can just add by 3. We're doing the same thing, but we're going in different directions. So what is 12 plus 3? That would be 15. So we get that our y-intercept is at 0, 15, or that the y-intercept is 15. So when you come on over here, you can use the blue color if you prefer. You don't have to. To find our initial value, we're coming back to where x is 0. If I went backwards on the x side, I should go backwards on the y side. Instead of subtracting by 3, I'll be adding by 3 here. So 12 plus 3, that gives me 15. You have to do the extra step of going back. So that's what it looks like there. And then before we go, we have 1 more minute left here. but I want to show you how the same is true. We're doing the opposite for the exponential side. So on the exponential side, finding your second step is to find that y-intercept. We're going to find that where x is 0. So wherever we see our x, we notice there's a 1. I would have to go backwards to get that 0. And now I'm going to have to think, well, some number here that when I divide it by 3, it gives me 81. We can think about it that way just by using your pattern. But some of you see it easier as going backwards. Well, no, I can just go backwards and do the opposite. Instead of dividing by 3, I can multiply by 3. And then I would get 81 times 3 is 243. So the y-intercept here is 243. All right, we're going to go ahead and finish this off. And then as soon as we're done, I just want to remind you that you are supposed to be completing your exit ticket. And if you did that and you have completed these notes here, then all you would have to do. Oh, I forgot. They do have that homework assignment, right? Oh, yes. Okay, really quickly before you guys leave, this is what your completed notes look like.
Yeah, we actually had a couple of kids who've already done it.
Oh, cool.
Yeah.
All right, so this is the completed notes. This is what they look like. Your homework assignment is actually something you guys are very familiar with. If you go to week 5, it says 13 homework linear versus exponential. That's actually in Classkick. And there isn't much of a difference from what you're used to doing here. But there's 2 pages for your homework assignment. All it is the your turn pages that you're used to doing. So you have some tables. In this case, you have the increasing tables. I want you to tell me if they're linear or exponential. If it's linear, what is the constant rate of change? If it's exponential, what is the constant multiplier? It's the 2 steps that we did today. And then find the initial value by going backwards. See how it's blue here? That's reminding you to go backwards for your initial value. Yes, and then write your reflections down at the bottom. There's 2 of those pages, increasing and decreasing. There it is. And that's basically it. There's also the assignment from your Google Forms, which tells you if you were right or wrong. If you want to go back and fix those and retry it, you can also do that. But at this time, it is time for you guys to go. So make sure you completed your exit ticket, that you turned in your Desmos activity, and this is your second homework assignment there. But we'll see you guys on Thursday. Don't forget your
Bye, guys.
tomorrow.
Bye-bye.
Bye.
Bye. I'm gonna start putting people in the waiting room. Oh, I should also stop recording.